Thanks so much, Devin. Thanks to HeavyBit and Treasure Data for setting this up. So my name's Sasha. I used to be the CTO at Redfin. Recently I've been fun employed, and I've been traveling and playing a lot with React, and I'm excited to show you some stuff I've worked on. So we tend to think, to set the stage, we tend to think of React as a browser tool, or for those of you using React Native, as a client tool. But it's really important on the server as well. And I mean, actually, the fact that React has server-side rendering was the thing that originally attracted me to it. We were using complicated client-side JavaScript at Redfin, and we had a lot of trouble with SEO. It's very difficult. You can make a JavaScript, mostly JavaScript site SEO compatible, but it's very buggy. It's very difficult, and it just wasn't giving us the speed we wanted. And so, React on the server is really about getting speed, getting the HTML down to the client as soon as possible so the user really gets a great experience. But too often, it's kind of slow on the server. I don't know how many of you have tried it, have played around with it, but it can be kind of slow. So let's do a little demo. So I'm going to be going through a demo, a really simple benchmark. This is the component I'm going to be rendering. It's a very simple component. Call it recursive divs, and it just generates a giant tree of divs. Takes two properties, a depth and a breadth. At depth 0, it just returns a simple little div with like 10 characters. And if depth is higher than 0, it recurses down in an array of children. Also puts on an on-click handler just for fun. But other than that, it's pretty simple. So this is just a very simple component that can show you giant component trees. We have a benchmark function here, and this is also pretty simple. This is just a file that's exporting a method to be benchmarked. And all it's doing is just calling getting React DOM server and calling render to string with a depth of 4 and a breadth of 11. So let's run that and see what that looks like. I'm using benchmark.js for the benchmarking, so it takes a little while, especially on this first one because it's kind of slow, to get statistical significance. I picked the depth and breadth. It's a pretty big, it actually makes a pretty big document. It's about 900 kilobytes. But I was actually, and that may sound like, oh my God, that's huge. But the other day I was looking at like the Facebook news feed, the Twitter feed, and just when you load the Twitter feed, it's over 1 megabyte of HTML in your browser. So 900 kilobytes is not actually that crazy. All right, so it took over a second to generate that page. That's really, really bad performance. That's not good, right? We can't have a server that's taking a whole second to generate the HTML and at most getting 1 hit per second. So let's see what we can do about that. First off, just stepping back, why does speed suffer in React Server? I think there are 3 basic reasons. First off, render to string, it's running in Node. It's single-threaded. It's single CPU. It's synchronous. These are all things that are going to make it, it's CPU bound. And Moore's law has been holding, and servers have been getting faster, but mostly in multi-core, not in single-core, right? Single-core performance actually hasn't been getting much better over the years. It's getting a little better, bit by bit. The other reason I think React on the server often is not as fast as you'd like it to be is that server rendering and client rendering share the exact same code path. This is really great for code reuse, and I understand why the engineers working on it did it. But there's a ton of stuff that you have to do for the client that you don't have to do for the server. Things like keeping track of a virtual DOM. There's no reason to have a virtual DOM on the server. Keeping track of all the event handlers. No reason to have those on the server, and yet it has to do all that code. And the last reason, I mean, the core reason really, I think, is that Facebook isn't using it in production, at least as far as I can tell. And I say this not to cast any shade at Facebook. I think Facebook is amazing. I think it's amazing that they open sourced React. And it's a really, really cool product. And I think it's actually amazing that they put this feature in that's really important that they don't actually get much benefit out of. But they more or less said at the React conference when somebody asked about performance in server-side rendering that they don't use it, so they don't prioritize it as much as they might if they did. But the cool thing is that means that we get to work on it and make it better. So I'm going to tell you 6 weird tricks to improve the performance of your server, a React server. Quick disclaimer, though. I'm talking about the amount of time it takes to generate the HTML, which is really only a small part of how your web page, your web page performance looks. There's lots of other stuff going on in the web in your web app, loading JavaScript, loading CSS, yada, yada, yada. If you haven't read these 3 books on web performance, just don't even listen to the rest of my talk. Download them, start reading them now, because any of the tips I tell you will be absolutely useless unless you follow the things that these folks tell you first. All right, so my best try at a clickbaity title for this talk, 6 weird tricks. Okay, the first one isn't really weird. I bet 90% of the people in the room know it. It's production mode. Okay, this is pretty obvious. But it's super important. If you don't use it, it's really bad. All you have to do is just set node-env to production. Let's see what that does in our little test here. All right, we run that, and this is going to run a little faster. While we're waiting for that, I'm just curious, how many people here use React on the server side? Okay, actually more than I thought. Nice. And who here uses it for SEO? Wow, like one, oh no, okay, a few, 2, 3, or 4. All right, 263 milliseconds, so that's about 4 times faster. Okay, clearly that's an obvious good win. Why is that? Well, it turns out one of the things that's really great about React as a developer is that there's a ton of good error messages in React, and really thoughtful, I think, intensively sort of helpful error messages. But they're really expensive to do all those checks for the error messages. So running in production mode doesn't do, basically cuts out all of that code, and it's actually spending, 3/4 of its time just in developer warnings. So that's a simple one. Downsides to production mode, there basically aren't any. Let's move on. All right, weird trick number 2. Use the minified version of React that's packaged for the browser. Now, you may have read on Stack Overflow, you may have seen on various things like, no, you don't have to minify code for .node, and in a general sense, that's true. But it actually really helps with React, and I'll talk about why in a moment. First, I'm just going to say, how do you do it? It's pretty simple. All you have to do is just change the import, or if you're using require, change the require from React DOM/server to React dist React min. This points at, if you're using the NPM version of React, this points at the browser, minified browser distribution of React. And let's demo that. I say demo, but this is really just coding and running the thing over and over again. Okay, react.min. It's that simple. And we'll run this. Okay, so I'm curious, of the people who are using React on the server, how many knew about using the browser version? All right, nice. And right here, okay, we got a couple people. I'm hoping, my hope is I get one tip that stumps everybody. Okay, that cut off about 70-ish milliseconds out of the 260. It tends to give in my tests about a 30%, to cut off about 30% of the performance. Why is that, do you think? The crazy thing is, once again, it seems to be those developer warnings. And it's actually, we cut out the developer warnings by running in production mode, but it still has to check whether it's in production mode. And it turns out, in Node, for whatever reason, checking process.env.nodeenv is really expensive. So it spends about 1/3 of its time just checking if it's in production mode and skipping the code. Crazy. There's been a bug on this in the React repo for 2 years now. I think they might fix it in 15 and make this the automatic thing to happen in production mode, but I'm not sure. Downsides to this, makes the server harder to debug, removes a lot of great dev warnings. Don't do it in dev, but product's pretty good. Third, Babel transforms. So there were 2 Babel transforms. Everyone knows what Babel is, yes? Cool. 2 Babel transforms added in React 14. One of them is called constant React elements, and the other one is called inline React elements. And they're both for performance. So the constant elements transform finds JSX in your code that is actually always going to evaluate to the same thing, that has no variables in it. And it will hoist that JSX to a higher scope, assign it to a variable, and then use the variable inside where that JSX used to be. Okay? This example might help explain. You have a component here. If you run the constant element transform on it, it will see that JSX right there, the foo bar, and it will pull it into a variable outside the scope. So now when render runs, the JSX doesn't have to run. Before the JSX was running, it was calling React create element every time render was called. Now it isn't. The inline element transform actually takes JSX, and JSX normally transforms into the call React create element at runtime. What the inline transform does is it actually does that call essentially at build time and puts in and replaces your JSX with the object that would have been the result of React create element. As an example, the inline transform would find that and replace it with this crazy hell of objects that you don't want to see, but luckily you don't have to. To do this, you just have to install the two Babel plugins. The hardest part is remembering the names of these, I swear. And then you have to add these to your Babel config. That should actually be plugins, not presets. And just trust me, constant elements has to be before inline elements. I'm going to go ahead and demo that right now. I'm going to pull up my Babel RC, which is my Babel config file. And we're going to test my typing skills here. Transform constant, nope. React constant elements, transform React inline elements. Okay. Sorry? Thank you. I love having cheerful folks. Now, I'm guessing the folks who knew about the browser one knew about the Babel transforms, right? No? Oh, okay. Oh, I got one, yeah. I'm excited. All right, we'll see. Should almost be done. All right, yeah, so this one, in my experience, only shaves about maybe 10% off the performance. Not amazing, but certainly worth it. It's not very hard to do. Also, as a side note, those of you who aren't doing React server rendering, both of those transforms can be used for client-side and help the performance of client-side as well. All right, downsides of it, requires a Babel build step, but almost every React project right now these days has a Babel build step, so that probably isn't much of a downside. All right, weird trick number 4, avoid create class. Turns out components that are created with React.create class significantly slower than ES6 components and stateless components. And I'm just going to go ahead and demo that. This is a little bit of a longer one. This is one of the fun ones to see if I can really know. So right here, I've got one that's with traditional React create class, and I'm going to change it to an ES6 class. Change that to class, change this to extends, React.component. Then get rid of function, because who needs that? Get rid of a comma, because commas are evil. Get rid of function, get rid of that. And then one thing that's, that you can easily miss when you do this is that in React.create class components, everything is auto-bound. And so you have to make sure you bind your element handlers when you switch them over to ES6 components, because ES6 components methods are not auto-bound to the instance. All right, let's save that. And back to our trusty thing. So can I ask, who knew this as a performance tip? Oh, right. I haven't seen it, nice. I haven't seen it published anywhere. I tried it on a whim, frankly. All right. Yeah, right? It's crazy. I love that, like, my demo is 66, like, being typed up in Courier and be like, woo. Okay. Why does this happen? Honestly, I don't know, and I haven't had time to figure it out. I have a suspicion with no data. I suspect the auto-binding, but I'm not sure. And I just haven't had time to look into it. I've been hacking around. All right, so we've gotten it down from over a second to 66 milliseconds, which is pretty darn good. But I wanted to see if we could do better. First, the downsides of doing ES6 classes. It can be a lot of work to change your code from one form to the other. It's relatively mechanical work, but it is bug-prone, especially the auto-bound handlers, so be really careful. Also, one downside, some people hate ES6 classes with the fire of 1,000 suns. I don't understand it, but if you're one of those, that's a huge downside for this. Okay, so weird trick number 5. Streaming. So One of the things that browsers are actually shockingly good at is dealing with fragments of HTML documents. We often think that, that we have to generate an entire document and then send it down to the browser, but that's not what browsers are expecting. Browsers are really used to HTML being sort of trickled down from the network, and they're really good at displaying and rendering partial documents. And you can use this to your benefit. For example, imagine you were in charge of Google's results page. Maybe somebody here is. And I don't know. And somebody sends you a query. They want the search results page with the term React. You could serve them up this header without talking to your backend at all, right? You could start sending them down HTML with this header because it has no information about how many search results or what the search results are. It's just basically static information that you already know. So you can send off an asynchronous request to your backend to find out the search results at the same time that you're sending HTML down to the front end. And the browser will display this. And the user will think that the page is loading, even though it isn't totally loading. It's only partially loading. So the user will actually see this. And if your backend is hiccuping for some reason, they'll see this, and they'll sort of think, oh, it's there, before they get the actual results. And I know that Yahoo did this for a long time, and I think Google did it as well. With instant search, I think they may not do it as much as any of it. For those of you who want to know more about this is called chunked encoding. It's been part of HTTP since 1999. I think it's supported in every browser you can possibly imagine. It is criminally underused, I think, as a performance enhancer for sites, that you can stream down HTML. You don't have to generate the whole page. Framework after framework forces you to generate the whole page before they send information down. It's just not great. However, for React, we know that React DOM's rendered a string just returns a fully rendered string, right? That's not going to help us because it does render the entire document, and then you send it down. So I went and made a library called React DOM Stream. I released this maybe 2 or 3 months ago, and it's a fork of React. A fork of React 14 that adds a bunch of, not a bunch, it adds basically a render method that outputs a stream instead of a string. So let's talk about, so the cool thing about it is that time to first byte, when you use React DOM Stream, stays constant as the content length gets longer and longer. So you can generate a 20 megabyte HTML page, and it still only takes a few milliseconds to get that first byte out of the render tree. The time to last bytes obviously scales with how big the content is, but it scales more or less linearly. And it takes about the same amount of time as React DOM. Okay, so if you want to use React DOM Stream, how do you do it? First, you have to install it from npm, obviously. Then you need to change your import statements. It's really simple. It's just React DOM Stream server. I tried to make it as similar to React DOM as possible. Then you need to change your calls, your render to string calls, to return a stream. What that might look like is something like this. This would be an express route where you've got res.send wants to take in a string. Instead, you just pipe it out to the response, because in express, responses are streams. It's a little more complicated than this, because you probably want to put HTML and body tag around it, and so you have to tell it not to end the stream. But this is basically what it looks like. All right, let's see if I can do the live coding on this one. I am not entirely convinced. All right, the first thing I'm going to do is I'm going to import a little thing I call timing stream, which is just a really simple stream that throws away the bits but emits 2 different events: a start event when it gets its first byte, and a finish event that every stream emits when it gets its last byte. So now, instead of rendering to a string, I output to a stream. I'm going to pipe it to a new timing stream. And then on start, which is when the first byte comes in, I'm going to do something. And this is where things get a little funky, because we have to make this test is now going to be asynchronous. We have to tell the test when it finishes. And then we'll unpipe the stream. Okay, that looks pretty good. They may catch me make a mistake. Speak now. All right, and I'm going to do it twice. Once with start and once with finish. Because I actually want to test both things, because now we've got sort of two moments we're looking at. When the first byte comes in, TTFB and TTLB. Render 2. All right, does that seem, oh, I have to say that they're deferred tests. And there's one more thing I need to do. What is it? Thank you. Change the import. React DOM stream server. Does that seem right to people? Is anybody paying attention? All right, we'll see. I count on you all to watch out for me. All right. Has anybody heard of React DOM stream? Oh my God, you're my favorite person. All right. All right. So first byte came in 4 milliseconds. Last byte came in 62 milliseconds. So you notice the last byte actually came in before the full thing did. The full string came from React DOM. And the first byte came in 4 milliseconds. That's awesome. We can get the markup down to the browser as quickly as possible. When you think about it, this makes sense. I mean, the renderer is doing a depth first traversal of this tree. It should be able to start outputting really almost immediately. Okay, so that's pretty cool. Let's look at so downsides to this, to using streaming. First off, it's beta, and it's made by some guy. I could totally vouch for that dude. No, I mean, he's shifty. So you need to decide what your risk tolerance is. I would say it's not like moving everything to ES6 classes. It's not as, I don't think it's as likely to cause bugs, and it's pretty easy to revert. Like you saw, it was just changing the stream just back to string and changing the import. Another thing to watch out for is intervening HTTP proxies between your server and your user are actually allowed to coalesce the response and basically stop the streaming. And we had like months on phone calls with a CDN I shall not name, trying to convince them that streaming HTML was a normal thing, chunked encoding. So just be careful of that, especially if you have a CDN in front. All right, last, one of you, hold questions for the end, how about? Last weird trick number 6, cache components. Okay, so I wanted to see if it could get even better than that, like 4 milliseconds to the first byte is great, but still 60 to the last, and is there a way we could do better? And so I started thinking about caching, and caching on the server has traditionally been this really difficult, really messy thing. I mean, it always starts out really simple. You're like, oh, I'm doing the New York Times. The newspaper is just the newspaper. I can just cache it, right? And it'll look great for everyone. But then you're like, wait, if I cache it for a few minutes, well, these are ads that really should be different for every person. And, oh, there's this stock market thing that needs to be updated every few seconds. And it actually includes the person's login menu, so that needs to not be cached. And actually, maybe this whole layout is part of an A/B test, and there's multiple of them. If I cache them, I'll destroy the A/B test. Because it turns out page-level caching is just really bad idea, right? And this is always what happens when you try and do page-level caching. But React is really good at breaking pages down into smaller, more reusable pieces. And I was thinking it'd be really cool if we had component-level caching. And so if you do that sort of immutable state functional programming thing people like to think about React, and if you think about React components as props and state, just a simple, pure function of props and state that maps to a string when it's on the server, just mapping to a string, that's, as a functional programmer, you just think, oh, we can just cache those. We can memoize them. Like that's what, if it's a pure function with no side effects, we should be able just to cache this. So I went ahead and hacked this into React DOM stream last week. So if you want to use it, install the beta. You really shouldn't use it. And then you need to add a cache object to the render to string method. It looks something like this. I'm going to go pretty quickly through this. Just add a cache to the end of that render to string. And then you need to actually have your component opt in, because it's really dangerous to cache if you don't have the right cache key. So basically, you have to implement this method in your component called component cache key, which outputs a string. And that string has to include all of the properties that are used as inputs to the render method. This is because you have to do this for the cache, because otherwise we could end up getting false cache hits, which is really bad. So it's really important that you explicitly tell the framework all of the things that are going to be part of your render method, inputs into your render method. Let's do a quick demo of that. How do I do this? What's this? Oh, right. So the first thing, I'm going to import the LRU render cache from React DOM stream LRU render cache const cache 1 equals new LRU cache. And I will say this API is very new as of a few days ago. It is liable to change. If you want to use it, let me know, and we'll talk about it. Because I think it's kind of a neat idea, but it has not been used in production. And what could possibly go wrong? All right, so you add the cache as an optional argument at the end of the render to string. We created the caches here, and now we need to go over to the component, and we need to add that method I said, which is component cache key, which I think needs a better name. Now this component is really simple. All it needs is, it only depends on its depth and breadth, and it's a pure function of those two variables. So I'm just going to do something simple and say stringify this.props. That should give a cache key that will be unique for every different rendering of the component. All right. Now I know nobody's heard of this one, because I've literally told no one. Are you ready to be amazed? Are you ready to be amazed? I'm ready. All right. So yeah. Hold your applause, I'm cheating. I mean, no, seriously. I mean, that recursive divs thing, you give it a depth and a breadth, it gets in the cache the first render, and it just pulls it from the cache the second render. Like this is the best possible case for caching, but I still think it's pretty cool. And it has, I think, a lot of potential. It has some downsides, right? Alpha quality, I already said that. Nobody's tried it in production. Nobody knows about it. As with all caches, if it has a low hit rate, if you are rendering things that are totally different all the time, or your components are getting different props all the time, caching is just going to be a net negative. It's just going to be a drag on the system. It's also super dangerous. Caching on the server has this problem. I don't know how many of you saw what happened to Steam on Christmas. Yeah, right? So those of you who don't know, Steam had a bunch of problems, and their ops people, God bless them, were having terrible problems, and they made a mistake in trying to bring their systems back up, and they misconfigured a cache, and then people started getting other people's account pages because they went to the account page and they got a cached version, which is bad. So if you get the cache key wrong, that cache key method can serve personal data to the wrong person. This is true with any, this is not just this this component. This is any kind of server caching. All right, so recap of my 6 weird tips. Should I use these? That's a good question. So production mode, yeah, you already should have been. Minified React from the browser, yes, I think it's really easy. It gives a ton of performance. Babel transforms don't give a lot of performance, but they're really easy to do. ES6 classes and stateless components, maybe. That's one where you really have to say how much work is it going to be. Are there maybe like 3 components that are used all the time throughout my render trees, and so it's going to be a small amount of work? But it could really introduce bugs. Streaming, once again, I wrote it, but maybe. I think it's really cool, and I would love for people to try it out. And if you try it out, please let me know so I can find out about how it's working for you. But it's definitely more beta. Caching, probably not yet. If you want to work with me and make it better, that's great. And I think there's lots of things that can be done to make it better. But I wouldn't use it in production yet. And that's it. Thank you so much.